Hey everyone, we're gonna do methods today. I've been a bit lazy with making and editing and the videos, but hopefully I'll catch up soon. So today is the 31st of October, it's Halloween, and I sat the chemistry exam today. I thought it was about equal difficulty to all the other exams, or all the prac exams. I already know I messed up a few of the last calculations because there was a few steps I didn't do properly. Some of the multiple choice are also a bit weird, so I'm probably leaning towards the lower end of my prac marks, so maybe 89, 90, that sort of area. hopefully, I did all right. Also, Andrew, if you're watching, hello, how are you doing? Today we'll be doing calculator 3 in the 2021 WACE exam methods. I didn't do like 19 or 20 because I think I'm only gonna have enough time to do about 3 exams until actual methods, and then obviously there's no point doing methods exams past that. So yeah, we'll just do 2021, 22, and 23. Should be plenty of practice. Looks like we have 11 pages to get through, so we might as well get started. 50 minutes on the clock. Right now. Differentiate this. Simplify my answer. So derivative of the top is just 3 x to the power of 3, and then derivative of the bottom is 3x squared, 3x plus 1 over x to the power of 6. So if we expand this out, we get 3x to the power of 3 minus 9 x to the power of 3 minus 3x squared all over x to the power of 6. We can simplify this to minus 6 x to the power of 3 minus 3x squared on x to the power of 6, and we can cancel out this x squared term, so minus 6x minus 3x to the power of 4. Let f of x define a simplified expression for the rate of change of f of x. So we want the second derivative. There's going to be product rule. Derivative of x is just 1, so this will be ln of 2x plus x times the derivative of ln 2x is going to be 2 on 2x, so it's going to be 1 on x is equal to ln of 2x. Obviously x times 1 on x is just going to be 1, so bada bing bada boom, because derivative of this is going to be derivative of the inside function over the function itself. Derivative of 2x is 2, and it'll be over 2x. These 2's would cancel. Okay. Yep, that's what we needed to do. Given that and determine g of 5. So let's see. G dash and g1. So I want to find g of x is equal to the antiderivative of this. So what I want is a 2 in front of the e, because that's my derivative. So I'm just going to bring this 2 out. 2e 2x dx. So now I can anti-differentiate this, which is going to be e to the 2x. And then we got to add a plus c. Now we can check this because the derivative should be this. So if I differentiate this, I put the 2 in front, that's going to give me 4e to the power of 2x. So that's all good. And then g of 1 is equal to 0. So I can say that 0 is going to be 2e to the power of 2 plus c. So then c is equal to 2e2. So then g of x is equal to 2e2x. It should be negative. Minus 2e to the power of 2. If I sub in 1 there, yeah, that was good. It takes Nayun between 15 and 40 minutes to get to school every day, depending on the traffic. Nayun leaves home at 8 a.m. every school day. The random variable x be the time in minutes after 8 a.m. that Nayun arrives at school. Probability density function is shown below. So this would be a uniform distribution. Okay, determine the values of p, q, and k, and X is the minute after 8 a.m. he leaves from school. So P is our lower bound. So P will be 15. Q is equal to 40. And then K is going to be 1 on 40 minus 15. So it's going to be 1 on 25. Because here between 15 and 40 and K is just a value, so that P minus Q times K is equal to 1. So K is 1 over Q minus P. Because this will make a rectangle and the area should sum to 1 because we're finding probabilities. So then K is equal to Q minus P, so 40 minus 15, so 1 on 25. The expected value of X is just going to be the midpoint. So we can just do 40 plus 15 all over 2. That gives me 55 on 2, so 27.5. Or if you want to do it the weird way, you can integrate from 15 to 40 of 1 on 25 dx. That'll give you 1 on 25 times 40 minus 1 on 25 minus 15. Ignore my alarm. That'll be 8 on 5 minus 15. Wait a minute. Oh, because I have to have that dx. So now it'll be 40 squared. And this will be squared, and this will be on 50. Oh yikes, that's going to be ugly. But yeah, that should give you the same answer. I'd have to find the midpoint. The probability that Nahum arrived at school before 8:25 a.m. is going to be the probability. So I want to find the probability that X is less than or equal to 25. It's going to be equal to 25 on 1 on 25. Wait a minute. Before 8:25. Oh, 8:25, and it takes him at least 15 minutes. Okay, so this is actually less than 10, because if I have 25 here, then this length is 10 and 15, so it's less than 10. So then this would be 2 on 5. Just divide by 5. Now will be late for her first class if she arrives to school after, otherwise she will not be late. Otherwise she will not be late. If she is not late for her first class, what's the probability she arrives after 8:25 p.m.? So probability that X is less than or equal to 10, given X is less than or equal, so minus 15 is there, and 28 will be 13. It's going to be equal to, now the probability that it's less than 10 and less than 13 is just going to be the probability it's less than 10. So it's going to be 2 on 5 divided by 13 on 25, which is going to be 2 times 25 all over 5 times 13. So then, God, my throat is killing me. Yep. So then that 5 will go, these 5s will cancel, that becomes 2 on 5 on top, so that becomes 10, and becomes 13 on the bottom, so 10 on 13. If Nahum only wants to be late her first class 4% of the time, what time should she leave home? Assuming the 15 to 40 minute travel time remains the same. At most 4%. 4% is the same as 1 on 25. 1 on 25, thus max. Let's max 39 mins. Let's max 39. Travel time. Maybe not maximum is the best name. So then it needs to be 39 minutes before 8:28. So she should leave 39 mins before 8:28 is, let's see, 28, and then I have 11, so it's going to be 7:49 a.m. That was correct. Given that that equals that, increments formula to determine the value for 2.02. So let's see, ln of x. Let's let y equals ln of x. The derivative of this is 1 on x. So we know that let's write this as dy dx. And some small change of y is approximately dy dx times a small change in x. So approximately dy dx at 2 is going to be 1 on 2 times 0.02, because that's my change, which I can rewrite as 2 on 100. It's going to be approximately 1 on 100. For y of 2.02, it's approximately going to be 0.693 plus 0.01. So that's approximately 0.703. I believe. That's so good. I'll just say here dy dx, given that x is equal to 2 and s of x is equal to 0.02. I'm not sure if they're going to accept that, but whatever. Okay, determine the following. Okay. Raise the power by 1, divide by the new power. So 2 on 3, x to the power of 3 minus x on 4 all over 4 plus c. Sine minus okay, so this is an ln, it looks like, because I have the derivative of 3 minus cosine of x is sine of x, so that's going to be equal to ln 3 minus cosine of x from pi on 2 to 0. My specialist brain kicked in and I was thinking of what identity am I going to use, but no, don't need to worry about that. So here I just have ln of 3 cosine of pi on 2. I look at my unit, pi on 2 straight up, so that's going to be 0. So ln of 3 minus ln of 3 cosine of 0 is heading straight to the right, so it's going to be 1, so it's minus 1. So then this is equal to ln of 3 minus ln of 2. Doesn't say to simplify, but I'll just write this as ln of 3 on 2. yeah, I'm dying. d dy that. So this is just fundamental theorem. So I can just substitute this all in. Squared cosine of 2y. I believe. Because then this will be f of y. So we write this. A nice way to think about this is, let's actually, well, not actually, but let's like differentiate this and write it in actual terms. This would be capital F. So if we let f of x equals this lower bit, then this will be big F of y, because we sub in y first, and then big F of -1. But when you differentiate with respect to y, big F of -1 is a constant, so that becomes 0. So all we're left with is f of y minus 0. So we're left with f of y. So all we got to do is just sub in y into wherever x is, and then that will be our answer. So that should be it. It's not even like there's a negative or anything, or it's not a y squared or anything, so yeah. Determine the area between the parabola and the straight line y equals x plus 3. What, Matt? Okay, so between the parabola and the straight line, so let's find the intercepts first, and then I'm going to have to find which one's above the other, but we'll do that in a second. So these need to equal for x plus 3. So then I'm going to move everything to the left, so I'm going to get x squared minus 2x plus 0. So obviously that plus 0 just disappear, equals 0. So then this is x minus 2, 0. So then x is equal to 0 or 2. Let me just double check. That gets me 4 minus 2 is 2, 5, and 5. And then obviously the other one would be 3. Yeah. So now I have to find which way they're going to go. So this will give me x plus 3 and 1, or 2 and 1. I think this is going to have some weird roots. But the main thing I got to know is that it's an upwards parabola, and this straight line goes through 3, and it goes upwards like that. So they probably intercept, so I'm going to assume the straight line is below. Why can't I think of the midpoint of this? Two over 8, so -2 over 1 to -2 over 8. That's 2 over 1. This is 2. So -b plus or minus b squared minus 4ac 2a. That gives me 1 plus or minus 1 minus 4 times 1 times 3. Oh, it doesn't reach the bottom at all. What the heck? 2x minus 1 equals 0. X is equal to a half. When x is a half, I have a quarter plus 3. Yeah. And then when x is a half here, that gives me 3 on 2. I'm sorry. 3 plus a half is 7 on 2. Half. So this is bigger at that point, at the midpoint. So I know that the line is going to be taller, definitely. Therefore, area, or above, I mean, is going to be from 0 to 2. I'm going to have x plus 3 minus x squared minus x, so that's going to be plus x, and then minus 3 dx. It's going to be from 0 to 2. Of the 3's will cancel, so I have 2x minus x squared dx. So raise the power by 1, divide by the new power, x squared minus x to the power of 3 on 3 from 2 to 0. Now I can already see that if I plug in 0, I'm going to get 0. So I only have to worry about the top term of 2. So that's going to be 4 minus 8 on 3. 4 times 3 is 12. 12 minus 8 is 4. So this is 4 on 3 units squared. And we move on. The area between that and that is the same as determined in part A. Explain why this is the case. We can see that moving, it just simply moved the parabola and the straight line down by 2. So y x, sorry, let's say x minus 2 is x squared minus x plus 3 translated down 2 units. No, sorry, translate down 5 units. And then x minus 2 is x plus 3 translated down 5 units. As both are translated, as both graphs are translated, or maybe not graphs, I should say functions. Functions, come on, translated down by the same amount. The area between them doesn't change. Okay, graphs of 3 binomial distributions. Blah, 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 blah. What is the mean of distribution A? 2. Which distribution has the largest standard deviation? Justify answer. So it's going to be C, because its values are more spread out. Is that a valid explanation? More spread out values. And you see here it goes from like 7 to about 1 or 2 even. But then something like this B only goes from 0 to 4 to 6. Random various normally distributed distribution is graphed below. 0 to region corresponding with 6 to 9. So this will be full lines. 6 to 9. So greater than 0.5. Justify your answer. I'm thinking no, but is this a thing where I have to count the squares? How do I justify this? I'm gonna say no. Maybe the area. I don't know the word area. X is not half of the area under the. It's not at least. Under the binomial distribution graph. It's under the normal distribution graph, not binomial. Normal distribution graph. Around variance probability is y is equal to that. Explain whether it's possible for the distribution of y to be normal or binomial. Normal distribution is continuous. probability of, say, y equal to 2 equals to 0. Therefore, probability of y greater than 2 must be equal to probability of y is greater than 2. Thus cannot be. Thus, y cannot be. Let's put in brackets here. Not probability of y 2 must be greater than probability of greater than 2. Y cannot be normal. And then here I'll say that binomial distribution is discrete, where the probability of y is equal to 2 is greater than 0. Therefore, probability that, oh, it feels so good to be able to use 3 dots again. Y is greater than or equal to 2 must be greater than 2. Y greater than 2. Thus, therefore, y can be binomial. This can be, or y is possibly binomial. There you go. Okay, consider the function f of x, 1 of x, graphed twice below. What's the difference? No, there's no difference. Shade 2 different regions, each with an area of exactly ln of 2. So I can go, let me think about this. If I want the area, it's going to be the derivative of 1 of x dx, so it's going to be ln of x. So I can either go from 0 to 2, or I can go from 4 to 2, I think. No. Sorry. 2 to 1. Because I can say that ln of 2 equal to ln of 2 minus ln of 1, because ln of 1 is 0, or ln of 2 can actually be ln of 4 minus ln of 2, because this becomes ln of 4 on 2, which I'm sure you can see why that equals ln of 2. And since this is just my upper bound and my lower bound, I can shade those regions. That'll be a bit nicer, my shading. Just like this. And then for this one, I'll do just like that. Okay, given that that was the relationship between A and B, we can say that B minus A equal to, so this would be ln of B minus ln of A is equal to ln of 3. So then ln of B on A is going to be equal to ln of 3. So then B on A is equal to 3, or B is equal to 3A. Oh, okay, I see now. Yeah, because you could have done then 6 to 3. Interesting. So B is equal to 3A. Upper bound is 3 times as big. Another graph is shown below. Is this the end? Well, this is the end. Okay. But considering the areas, oh my god. Okay, well, here we go. Let's do an underestimate area. So we'll go from, how big are these? So it's 2 times 1 on 2 plus, oh wait, not 1 times 1 on 2. Well, that's clearly not going to work. Oh, between 2 and 3, not between 1 and 3. Okay. 2 and 3. So this is a half of, I'm getting 2 on 5, and then 1 on 3, which is going to be equal to half of, that's going to give me 6 on 15 plus 5 on 15. So yeah, 11 on 15, which is going to be 11 on 30. And then over estimate of area. It's going to be equal to a half of 2. I'm going to get a half plus 2 on 5. So a half of, that's going to be 5 plus 4 is going to be 9 on 10. Is that 9 on 20? Yep. And then I'll say 3 on 2 of 1 on x dx equals actual area on the curve, actual or exact, thus it must be underestimate. I have some time, so I write the full thing. Underestimate must be less than 3 on 2, 1 on x dx, which must be less than the overestimate. So then 11 and 3, but I started to write thus more than I do my 3 dots because of chemistry. Less than, it was 9 on 20. Hence sure that. Okay, so then I have to do the actual integral. 3 on 2, 1 on x dx is equal to ln of x from 3 on 2, which is then going to be equal to ln of 3 minus ln of 2, which is equal to ln of 1.5. Therefore, 11 on 30 that's only equal to, sorry, just less than strictly ln of 1.5 less than 9 on 20. It's 3 divided by 2. Oh wait, that was it. Okay, nice and nicely done. We did it in about 32 minutes, slightly over halfway. So I'm gonna 1 mark. I'm gonna do the rest tomorrow because it's late and I want to get those other videos edited. And then we'll come back and we'll do everything else. So yeah, see ya. Actually, you know what? Let's have a quick skim through our answers. Let's just see. So derivative of the top is 3. Derivative of the bottom is negative, or 3x squared. 3x about 3. 9 minus 3x squared. Negative 6x divided by x squared. Looks all good. And of 2x, yeah, this one was, well, that was 3 marks. I don't think there's anything special there though. Determine give x, give 1. So then antiderivative 1. Okay. Oh. Determine g of 5. Good thing we caught that. So that'll be e to the 2e to the 10 minus 2e2. I think that's all good. Okay. It's definitely uniform distribution. P, Q, and K. So after 8 a.m. So 125 expected value is 40 plus 15 is 55 on 2. 27.5. Before 8:25 a.m. It means it will be 25 minutes. Oh, P. Sorry, no. This shouldn't be that. It should be less than 25. It's 25 minus 10, or minus 15. What is that? 10 on 25. Wow, good thing we are checking. I should like do this checking thing more instead of just saying I'm finished. 23. What would probably be the shoe rise after 25? Why not? It should be 25 and 28. There's 28 and 13 on 25. So this is 2 on 5. It's 25 on 13, which is what I had. So then divided, it becomes 2 times 5 over 13, so 10 on 13. At most 4% of the time. What time should you leave home, assuming that it remains the same? So 4% is 1 on 25, because it's 4 on 100. So then you can have, how much of the time? Because 96% is equal to 24 on 25, which is the same as probability of x is less than 39. And 39 minutes before is 8:48, 7:49, collecting 11, and 28 minutes. And then ln of 3 is increment form to determine approximation. So we have ln of x, dy dx is 1 on x, dy dx, so x is 2, and then the small change is 0.02. So 1 on 2 times 2 on 100, the 2's cancel, I just get 1 on 100. And then this is 0.01, just make that a bit nicer. 0.703, then the following, raised to power 1 divided by new power. You can also, raised to power 1 divided by new power, I can also differentiate and see if I get the same answer. d dx cosine of x is negative sine of x, yes. So it's 3, it's just that. Cosine of pi on 2 is 0, cosine of 0 is 1. And 3 minus ln of 2. This one, we sub in the y, yep. Term the area, so x squared minus x plus 3 equals x plus 3. X and x minus 1. So x equals a half will be the midpoint. So x equals 1 and 2. I think I did this already, but we'll just do it again. So 1 on 4 minus a half plus 3 is negative 1 on 4 plus 12 on 4. So that's 11 on 4. This becomes 7 on 2, which is 14 on 4. So yeah, the line is taller than that because the line would be above, because this would be 11 on 4, whatever it was, and this would be 14 on 4. So the line is above the parabola. It doesn't make sense because we've got a positive area here. So then we go from 0 to 2. The 3's cancel out, so 2x minus x squared. Raised to new power, raised divided by new power. The bottom, the 0 will just be 0, so that's 4 minus 8 on 3. So that's 12 minus 8, which is 4 on 3. Then here, translated 5 units down. Yeah, I'll just show it here. X squared minus x plus 3 minus 5. And then x plus 3 minus 5. Translated by the same amount, the area of its mean doesn't change. Mean of distribution A is 2. What's the distribution of the largest standard deviation? C, more spread out values. Or encompasses more values. Larger variance. More spread out values. Yeah, that's a flatter shape as well. Flatter shape. Calculate the region corresponding. Is that greater than a half? Area from, or area under. It's not really, it's half of the area. I think it's not at least half. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And then this is 3 times 1, 2, 3, 4, 5, 6, 18. Yeah, hopefully not. Okay. So the area under that is not at least half of the area under the normal distribution. Normal distribution is continuous, so it'll be 0, so these will be equal. But binomial, the probability at y equals 2 has to be greater than 0. So including y is 2 is going to be bigger than excluding y equals 2. So y is possibly binomial. Function ich brauche b minus a. So 1 to 2 and then 2 to 4. Relationship between a and b. And b on a is 3. Consider errors between y. So underestimate, overestimate, and then that. Okay. 9 minutes marking. I'm pretty happy with it. We caught some at the start, and then we fixed up one down here as well. So hopefully everything will be good. So yeah, I'll see you guys later. Okay, time to do calculator assume. We got 1 hour 40 minutes. Might as well just get started. Let's go. The weight W of carrots sold is bound to be normally distributed. It's determined the percentage of carrots sold. The supermarket weigh more than 155. So let's say W is normal distribution with a mean of 142.8 and a variance of 30.6 squared. So probably W is more than 155. Since it's the first time, I'll show how I'm doing it. Norm CDF of 155 to infinity of my standard deviation and 142.8. This is infinity 30.6, 142.8, 0.3451, which is equal to 34.51%. Carrots sold are classified by weight, shown in the diagram. So, complete the probabilities. So I have to go negative infinity to 110. This is 0.1419. And then this is so this will be 1 minus 0.1419 minus 0.5131 minus 0.331. This is 0.014. Okay. With the carrots being sold at the ones that are not medium weight, what proportion is small? So medium is 0.51. So this would be 0.4869. 0.69. What proportion is small? So 0.1419. So 1419, 0.4869. 0.2914. What percentage? No. The supermarket sells bags of mixed weight carrots with 12 randomly selected carrots placed in each bag. Okay, we're back. Let's continue. So this one, this is going to be a binomial distribution. So let's say X is a binomial. And we're going to have 12 trials. And we want them to be small carrots. So 1419 for my success. And the probability that x is at most too small, so it has to be less than or equal to 2. It's equal to, this will be binomial CDF from 0 to 2 of 12, 0.1419. Been a minute since I did a methods exam, so I just got to remember what all my parameters are. 1419. So I get 0.7633. And probability, so I can write that. The interesting architecture companies design a building with a constant cross section, shown below. Reference the height of the building, remember that. Measured in meters. Determine the width W of the building to the nearest centimeter. So to W, so I'll say that h of x equals 0. We'll see what pops out. So solve for, oh, this is, I didn't realize how ugly this fraction was. 3 pi on 2 x squared 3 pi x minus 4. And then we give it the boundaries. So given that 0 less than or equal to x less than or equal to 2 pi. Let's see what we get. Okay, more solutions. I'm going to put this just in, let's change this. I'll go, what is this for? hx on graph. Cast graph. Roots at x equal. So let me go back to main, I'll copy and paste this. So clear. Do that. Analysis with the roots. So x is at 0. And then x is at 8.64. And near centimeter. So I'll give it one more. Okay, we're back. Okay, so 8635. What do we want again? W. So width is going to be equal to 8.64 meters, because that will be 1/10 of a meter, which is 10 centimeters, and then 1 centimeter. Let me just turn my brightness down a bit. Oh, I gotta put my timers on. Hold on. Now we're back. Okay, we just had like 3 interrupts in like 4 minutes or something. Anyway, so determine h dash of x. That is going to be 4 cosine of x minus 3 pi on 2 minus 2x plus 3 pi. Bada bing, bada boom. Determine to the nearest centimeter the value of x at which the height of the building is maximum. Let's take this maximum height. So then let h dash of x equals 0. And then I will differentiate that. Standing. Sine. Okay, excellent. And then I'm going to solve this for that. Okay. Oh wait, I have to put on the boundaries. Oh wait, there's only one. Okay, so this would be x is equal to 5.742. I'm not even joking, got interrupted again. Okay, anyway. So then x equals 5.742. So then h of x. Oh wait, hold on. We could have just done this on the graph. What am I doing? Let's graph it. Let's just make sure it's 5.742. So analysis, g solve max. H of 5.742 equal to 20.575 meters. Yep, doesn't go like to the nearest whatever. How many pages are there? There are 19 pages. Okay. The adventure company allows tourists to climb from the ground on the left of the building, then alongside the building to the top. The ground company has a platform that allows climbers to climb to the rest of the way to the top of the building. The second half of the climb. At the point where it is steepest, how high off the ground to the nearest centimeter is it positioned? At the point where it is steepest. Alongside. Wait, what is happening here? Climb from the ground on the left of the building, then along the outside to the building on the top. Platform allows to come to the rest. The platform is located on the second half of the climb. Second half of the climb, at the point where it is steepest. How high off the ground to the nearest centimeter is it positioned? Second half of the climb. So we'll say how am I gonna do this? Should I just do this in a graph? I just graph h of x. So graphing h dash of x, given that, so he wants half of the climb. So what's 5.742 divided by 2 is 2.871, less than or equal to x, less than or equal to 5.742. So graph this. Alright, copy u, x, I go menu, graphic table, review, boom. Given that 2.871. Why is my cat lagging? Come on, buddy. Less than or equal to x, less than or equal to 5.742. Okay. Graph this now. And then go to keyboard, go to Bing. So the analysis G solve max. My maximum is at CAS is loading 4.189. So then h of x of 4.189 is equal to given that x is equal to 4.189 decimal, so this is 15.93 meters. So then 15 meters, 93 centimeters from ground. This one, that's fine, to the nearest centimeter. So this one I'll say 8 meters, 64 centimeters. Okay, going down. Oh, we love it when a page only has one question. A charity organization has printed lucky 7 scratchy tickets as a fundraiser for use at 2 special events. The tickets contain 2 panels. Each ticket has the same number as the sample tickets shown below. They are arranged randomly and hidden within each panel. Okay. A player scratches one section after every number. The 2 numbers revealed are then added together. If the total of 7 or higher, the player wins a prize. At first event, 400 tickets are purchased and a prize is won. 124 locations. Let P denote the probability that a prize is won. The first event. Okay, so we'll do P is equal to sample proportion. So 124 on 400. This is 0.31. Show that the probability of P, or winning of prize, is 7 on 24. So there's 8. Turn off each panel. The total is 7 or higher. The player wins a prize. The player scratches one section of each panel to reveal a number. Winning a prize is 7 on 24. So there's, okay, so it's 8. So total is total possibilities is 48, and then winning possibilities is probably going to be 14. So winning possibilities, so for you can have 6 and 1, which there are 4 of. 6 and 1, 4, 6 and 2, which there are 2 of, and then 6 and 3, which there are 2 of, and then we can have 5 and 2, which there are 2 of, and then 5 and 3, which there will also be 2 of. Yep, and then if we can have 4 and 3, which there are 2 of. So then total is 6, 8, 10, 12, 14. Therefore, P equals 14 on 48, which is equal to 7 on 24. Nice. Calculate the mean and standard deviation of the sample proportion of times a prize is won when 400 tickets are purchased. So the mean is just going to be 7 on 24. And the standard deviation is going to be square root of P, which is 7 on 24, times 17 on 24, all over 400. I think I got that correct. 7 on 24 times 17 on 24 over 400. I get it, that is 0.0227. At the second event, 400s were again purchased if the sample proportion was 0.6 standard deviations from the population proportion. How many prizes were won at the second event? I'm going to assume that's positive. How many prizes were won at the second event? So they probably want me to do z-scores, so then they want that x minus 7 on 24 all over standard deviation, which is 0.0227 is 0.6. I should do p hat. So then p hat is equal to 0.6 times 0.0227 plus 7 divided by 24. So 0.3053. So the number is equal to, or I guess n. N is equal to 0.3053 times 400. 0.53 times 400 is 122.12. Therefore, 122. That was round down. A new political party, Sustainable Energy Party, is planning to have candidates run in the next election. Researchers collected data suggest the proportion of voters likely to vote for the next party will be 23%. 1 year before the next election, random samples of 400 were taken into a particular electorate. A p-note determined the sample proportion who were indicated they would vote for the next election. So p hat, or I should say as n, greater than 30, normal distribution. let x equal normal distribution, and we have the mean is going to be 0.23, and then the standard deviation, or I should maybe move this down. Not that far down. Let's say that mean is 0.23. So then standard deviation, or sigma, 0.23 times 0.77. I think, if I could do math, 90, yep. And then all over 400, which is the same as 23 times 0.77 by 400. 0.0210. So 0.0210, or just 21 squared. Okay. Calculate probability the proportion of voters likely to vote in a sample of 400 is less than 0.2. Okay. So then this is just norm. So I say probability of x being less than or equal to 0.2. It's going to be my normal CDF. And I'm going to say less than 0.2, so negative infinity to 0.2, 0.23, 0.021. Oh, no. 0.021 first and 0.23. So 0.0767. 66, sorry. Yep. Okay, I don't know why that's 3 marks. Maybe you get 1 for this and 1 for... Huh, I'm not sure. I'm not sure why that's 3 marks. 1 week before the election, researchers believe that the proportion of voters likely to vote for the party in the same electorate had increased. A random sample of 200 voters was taken at this time, and 55 indicated they would vote. Estimate the proportion of voters likely to vote in this electorate. So we'll say p hat is 55 on 200. It's going to be 11 on 40. I'm not sure what that is. 0.275. Makes sense. Yep, 25 and then 0.025. So 0.375. For 99%, what is the margin of error of the sample proportion of this voters in this electorate based on this sample? Okay, so for 99% confidence, k equals 2.57. 575 was it? 576. Let's see. Let me do that. Normal CDF. I want to solve negative x to x to 1 to 0 equals 0.91. 576. I don't have to say hence, therefore margin of error is going to be equal to 2.576 square root of 0.275 times 0.725 all over 200 to 275, 0.725, 200, 990. So margin of error is 0.0813. I'm not satisfied with that 3. Okay, based on this sample, calculate a 95% confidence interval for the population proportion of voters likely to vote for the Sustainable Energy Party in this electorate. Maybe the proportion. Okay, so then for K, or for 95% confidence, and that K is going to equal to 1.96. What is it for 90 again? Let's see, 1.64. 1.645. Okay. And from 95, is there any rounding to do? So 1.96. And then, so then, margin of error equals 1.96 square root 275. Let's make sure, yep, 0.725. Did I write 0.725 up here? I did. All over 200. So then this is 0.725 divided by 200. So this is 0.0619. Therefore, this would be 0.275 minus 0.0619. So 0.2131. That's going to equal up P. That's going to equal to 0.3369. Did the proportion of voters likely to vote increase in the year leading up to the election? Justify your answer. So 0.23. I'm going to say no because 0.23 is still in the 95% confidence. So no, as original, 0.23 is still within the 95% confidence interval. The analysis above models the number of voters likely to vote as binomially distributed. Then discuss the validity of any assumptions for the binomial distribution in this context. So binomial distribution is discrete. Let's talk about what the requirements are. Binomial distribution requires each event, so each voter, to have a consistent or constant and independent likelihood to vote for probability you vote. Analysis above knows the number of voters likely to vote. I'm a bit confused on what the analysis above is. Validity. Vote for the party. Do they have a constant and independent probability? Is it really independent though? I'm gonna say no because of things like political discussions, friends and family who they're voting for, stuff like that. So I'm gonna say these are not perfectly valid. As the probability not constant between each individual and is dependent on things like political alignment, or friends and family, political views, etc. Political views. Oh, I can't write today. Etc. Okay, page 10. We are halfway there. F of x equal that. Finally, some calculus. Let's go. Only took us half the exam. So f dash of x. The derivative of x squared is 2x. I'm just going to put ex. Plus the derivative of e to the x is just e to the x. So then that's x squared e to the x. So then I'm going to pull out a factor of x e to the x. And then, so then that's going to leave me with x plus 2. Nice. These calculus determine all the stationary points and determine their nature. So if stationary point, f dash of x will be equal to 0. So the 0 is equal to x e to the x, x plus 2. So then x can equal 0, or it can equal negative 2. Okay, all stationary points. I assume it wants the coordinates, so we'll do f of 0 is, that's 0 times 1, so that's going to be 0. And then f of negative 2, so here therefore 0, 0. And then f of negative 2 is equal to, so that's going to be 4 times e to the negative 2, so 4 on e squared. E squared, f4 negative 2, 4 on e squared. And then let's find the second derivative. Oh, this is going ugly. Do I find a second derivative, or do I use sign? We're going to negative 0.1, negative and a positive. I think it might be easier to do the sign test for this, because I'm going to get a lot of terms here, and I'm not sure I'm going to enjoy dealing with all of that. So let's do f dash of negative 0.1. That is I'm going to do this on a calculator. Oh wait, yeah, I can just differentiate this in my calculator. Okay, that's not so bad. Never mind. Oh, I can do that. So I'll do f dash dash of x, and I'll just say I did it on CAS. So that's gives me x squared ex plus 4x ex plus 2ex. Okay, and then boom 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 of 0. That's going to give me 2, which is greater than 0, therefore minimum point. Let me just double check. Answer given x is equal to 0. It's 2. Negative 2 is going to be negative 2 e to the negative 2, which is less than 0, therefore max point. Thus, we know that 0, 0 is min, turning point, and then negative 2, negative, 4 on e to the 2 is a max turning point. So f of, given that 4e negative 2. Yep, okay, pretty happy with that. Determine the coordinates of any points of inflection. So if inflection, you know that f dash dash of x is going to equal 0. So the 0 is equal to x squared e to the x plus 4x e to the x plus 2 e to the x. Cas. Oh, so that's going to be negative 2 plus or minus square root of 2. Oh yeah, because it just becomes x squared plus 4x plus 2 equals 0. So negative 2 plus or minus, and then it wants the coordinates. So f of negative 2 plus square root of 2 is going to equal to 2 plus square root of 2. Probably going to want a decimal. 191. What is the standard version? Yeah, no, I'm not writing that. Negative 2 plus square root of 2. I think it's fine if it's exact, and then this can be decimal. Negative 2 minus square root of 2, which is going to be 0.384. I have to sketch it. Okay. So 0, 0 was a minimum. Negative 2, 4 divided by e squared is 0.5. 54. So a bit higher than halfway. And then negative 2 plus square root of 2 is negative 0.585. So negative 0.585, 0.191. So about 6. And about there. And then the other one, which is negative, it's going to be on the other side, negative 3.414, 0.384. So negative 3.4, 0.384. And about there. Okay. So I would assume the graph is going to look like this. And it hits a maximum, and it goes down. And then it's probably just going to go up. So let's do x squared e to the x, given that x is equal to, let's say, find the value of 1. So that's going to be 2.7. And the value of 2 is going to be way above. So I'm going to go straight up like this. And then let's check this in the CAS graph. Because I mean, it doesn't hurt to just have the answer right in front of me. Yep, that looks like a nice graph to me. Pretty accurate at least. Maybe I'll smooth these out. So this is supposed to be concave down here. It's not swapping pens. We start concaving up, something like that. All right. Page 12. Carnival game. Oh, is there like no more calculus? Okay, there's one there. Okay, looks like calculus is coming up. Stay patient, stay patient. The carnival game involves five buckets, each containing 5 blue balls and 15 red ones. A player blindly selects a ball from each bucket and wins the game if they select at least 4 blue balls. So X denote the number of blue balls stated. State the distribution of X, including its parameters. So I have a total of 20 times 5 is going to be 100 trials, pretty much. So binomial. So let me think about this. So I have 100 trials, and oh no, they are consistent because you only select one ball from each bucket. So once you select one from one of the buckets, you move on to the next one. So the probability of containing a blue ball is going to be the same. Distribution of X, including its parameters. So you want to choose up to 5, not 100, sorry. And 5 out of 20 is 1, 4. So 0.25. Binomial. What's the probability of a player winning the game on any given attempt? When if probability of X, is it X? Yep. X is greater than or equal to 4. It's going to be, so binomial CDF. And 455 0.25 is 0. Does it want percentage? No. 0.156. 4 decimal places. Players are charged $2 for each attempt, and at the game, and offered 150 prize if they win the game. By providing numerical justification, explain why this is not a good idea for the carnival organizers. So expected value of X is going to be 0.0156. Actually, no, let's do this. Let Y equal dollar gain by customer, because it's much easier to look at it from the customer's point of view. So this is 0. So sorry, it's 150x minus 2. So then the expected value of Y is going to be 150 times 0.0156 minus 2. It's 2, which is 0.34. Therefore, in the long term, the carnival organizers will lose dollar 0.34. Sorry, I just got an email from my methods teacher. She just said, "Good luck for our exams on Monday." How nice. So we'll lose per game. Okay, an observer records the outcomes of 100 consecutive games and determines the 90 and 95% confidence intervals for the proportion. Which of these intervals is the 95%? So we want the one with the smaller standard deviation. So the standard deviation here, the midpoint is 0.1, so it's 0.6. So margin of error for 0.04, 0.16 is equal to 0.16 plus 0.04 all over 2. Sorry, minus. So this is 0.06. And then for 0.05, 0.15 is going to be 0.15 minus 0.05 all over 2, 0.5. With higher confidence, margin of error increases, therefore 95% confidence is the 0.04, 0.16 interval. I mean, I was putting back here 95% CI margin of error will be greater than 90% confidence interval margin of error. How many wins were observed out of 100 games? Both add up to 0.1. So then p hat is equal to 0.16 plus 0.04 over 2. That'll be 0.1. So then n is going to be 0.1 out of 100. That's just going to be 10 wins. Determine what you expect to happen if the width to the width of confidence intervals if 400 games have been observed. So margin of error is proportional to 1 on square root of n. 400, let n equal 400 and 1 equal 100. Therefore, n equals 4 and 1. 4 and 1. Thus, margin of error will be 1 on 2 and 1. Okay, let's just do this. Equals z that on square root of n equal to on 2 square root of n1. Thus, width of interval will be halved. Will be halved. For n equals 2 squared and 1. The true proportional wins does not lie within either of the above confidence intervals. Does it suggest that an error, sampling error was made? No. Because only 10%, oh no, sorry, I say 10% of samples made with 90% CI will not contain true P. Similarly, 5% of samples made with 95% confidence, or I should say confidence intervals here, and then 90% confidence, 95% confidence will not contain true P. It is possible that this was just one of those %, and 5% exceptions. Okay, the displacement in meters x of t of a powerboat t seconds after its launch is given by that. How far has the powerboat traveled before its acceleration is 0? What an ugly expression. My, oh my. Okay. Let's just expand. So this is 5t to the power of 3 minus 75t squared plus 240t on 6. So then velocity of t is going to be 6. Now this isn't really a quotient, is it? Because I can just put 1 on 6 on the outside. So I'll put 1 on 6. What happens if... So I'm going to square the bottom term. Okay, let me do this. Let's see what... Oh, okay, no. I can see why it cancels out. Okay, anyway, so this would be 15t squared minus 150t plus 240. So then a of t is a 6 of 30t minus 150. So then if a of t equals 0, 0 is going to equal a 6 of 30t minus 150. So then t is going to be equal to 5. So then x of 5, I'm just going to put this in a calculator. So CAS 5x x squared minus 15x plus 48 all over 6. Oh god, what is happening? Divided by 6. Given that x is equal to 5, that has traveled negative 8.3. Is that correct? X is 5. Yeah, that looks fine, I guess. Negative 25. How far has the boat traveled? So not its displacement. Before its acceleration is 0. So I don't want its displacement. I want 0 to 5 of v of t. So it's going to be 16 5t squared. Because I want the distance traveled, not the displacement. 15t squared. Minus 150t plus 240. And then I'll just put absolute brackets around this. And I'll say dt. And then so CAS. So then this is equal to this might take a while for the calculator to deal with, so put it in and then I'll quickly start moving on to the next question. $40 dx decimal. Oh no, that was very fast. Jesus. 81.667 meters. And it's in meters, yes. Looks all good. Okay, the graph of y equals m log 3 of that has a vertical asymptote at x equals 5. If vertical asymptote at x equals 5, then x minus p equals 0, or 5 minus p equals 0, so then p is equal to 5. If this graph passes through the points 6, 2, and 14 is negative 6, determine the values of m and q. So I have m log 3 of, so let's do 6 minus 5, it's going to be 1 plus q, is equal to 2. And this term drops out because anything to log 1 is going to be 0. So then q is equal to 2. So then m log 3, I'll say here this was 6, 2. And then this is 14 negative 6. 14 is going to be 9. Plus 2 is equal to negative 6. So then that's going to be negative 8. So m of 2, so 2m is equal to negative 8. So then m is equal to negative 4. Okay. An analyst was hired by a large company at the beginning of 2021 to develop a model to predict profit. At the time, the company's profit was 4 million. The model developed by the analyst was that where P of X is the profit in millions of dollars after X weeks, and A is a constant. Show that A is equal to E. We know that P of 0 is going to be equal to 4. So then 4 is going to be 20 ln of A all over 5. So then ln of A is going to be equal to 1. So A is equal to E. You just multiply that to get 20 and then you divide by 20. So A is equal to E. What does the model predict the profit will be after 5 weeks? So P of 5 is going to be equal to, in the calculator you go, so 20 ln of X plus E, so 1 all over X plus 5, given that X is equal to 5. This is going to be 4.087. So then profit will be $4,087,000 times a million. Yep. Showing the use of the quotient rule, determine the equation that when solved will give the time and the model predicts the profit will be maximized. So then I want dp dx is going to be 20. Okay, wait, hold on. Let me write p of x here. It's 20 ln of x plus e all over x plus 5. So p dash of x, derivative of the top is 1 on x plus e times x plus 5 minus, derivative of the bottom is 1, so minus 20 ln of x plus e all over x plus 5 squared. Now we can rewrite this as x plus 5 minus x plus e times 20 ln of x plus e all over, because if I times this by x plus e, that's just the same thing but times 1, but then I can have it in the denominator. So then this is minus x plus e times x plus 5 squared. So that is my ugly derivative. Then if I want, if max p of x, p dash of x must be equal to 0. Therefore we have that x plus 5 must equal x plus e times 20 ln of x plus e. Okay. Let's see, if I differentiate u, what do I get? A whole lot of garbage, but there's an x plus e and an x plus 5 in the bottom. X minus 20 times e -20 is x minus 5. Oh, that's why. No wonder my answer was a bit off. There needs to be a 20 in front of here. So yeah, move you a bit across. 20 times all of that. So then when I make them the same, I can get rid of that. And this can just be ln of x plus e. Always sneaky these natural logs. I don't need a double brackets. I can just put ln of x plus e. Okay. I think that's nicer. So then I get negative ln of x plus e times x plus c minus x minus 5. Yep, okay, what is the maximum profit and during which week will it occur? Well, if x plus 5 equals x plus e times ln of x plus e, then x is equal to, so answer equals 0. Oh wait, I'm in standard. Oopsies. Oh, never mind. Give me a decimal. 7.91. Let's see if I double check. X plus 5 equals x plus e. What if I leave that blank? And then ln of x plus e. Invalid syntax. Fair enough. Give me the same answer. Yep. Okay. So p of x of P791 is equal to come on now, this bad boy. And given that x is equal to 1.791, 4.436. Therefore, max profit is 4436123 in the second week. Wait. During which week? So this is after the first week, so it's during the second week. Cause if there's 0, there's 1, there's 2. After, because this is the first week, and then this is the second week, obviously, and I'm at 1.719, so I'm about here, so I'm obviously in that second week. Because 1 to 2 is the second week, not the first week. According to the model, during which week will the company's profit fall below its value at the beginning of 2021? So do P of x equals 4, given that x is larger than 0. So do cas solve u equal 4. I'm just going to ignore the 0. So 5.581. So then during that 6th week. Okay, the model proved accurate. The model proved accurate, and after 10 weeks, the company implemented some changes. God. From this time, the analysts used a new model to predict the profit. And was the profit $1 million? Y is the point in time. Y weeks from this point in time, and B is a constant, which I did. It's profit to exceed. During which week does that new model suggest this will happen? constant. Okay, so then let's do p of x, or p of 10 is equal to 3.391. Remember, after 10 weeks, implementing changes from this time. Use a new model to predict the profit. B. So then 3.39 is equal to n of 0. 3.391 equal to 2e b times 10 cas. I accidentally spat on my iPad screen. B is equal to 2e 10 of x 0.0528 and therefore n of y is equal to 2e 0.0528 times 10 plus y. Should exceed 5 million. Let's do n of y equals 5 cas, then solve 2e 0.0528 times 10 plus x equals 5. So then y is equal to 7.353. Therefore, in the I'm going to have 7 plus 10 weeks, so in the 18th week. In the 18th week. Okay. A resort in the Swiss Alps features a cable car that travels from the resort station to the mountain station. Engineers are fixing a cable car that is unexpectedly stopped shortly before it reached the mountain station. The engineers are ready to test the cable car. For the purpose of the test, the cable car initially be at rest in its current position, will head up the mountain, stop at the mountain station, and immediately return to the resort station where it will stop, and the test will be complete. The test begins, and engineers believe the acceleration during the test will be that measured in meters per minute squared. The variable t is the number of minutes from the moment the cable leaves position, and k is a constant. After 2 minutes, the engineers expect the cable car will be traveling with a velocity of 18 and will not yet have reached the mountain station. Determine the value of the constant k. Okay, so I get it. Okay, so we know that v of t, we're traveling with velocity of 18. So I want to find the antiderivative of kt squared minus 23t plus 20k, and I'll find the respect to time. So raise the power divided by the new power. This is k on 3, t to the power of 3 minus 23 on 2 t squared plus 20, yeah, because it's dividing by 1t plus c, and then v of 0 was 0 because we initially started at rest, therefore c equals 0, therefore v of t is k on 3 t to the power of 3 minus 23 on 2 t squared plus 20 kt. Then 2 minutes, so v of 2 is going to be v of 2 is going to equal 18. So then 18 is equal to 8 on 3k minus, that's going to be 4, so I'm going to have 2 of that, so it's going to be 46, equals 23 on 2 times 4. I cancel that out. That becomes 1. It becomes 23 times 2, which is 46, plus 40k. Then adding that over, that becomes 64 equals, is that 64? 58, yeah, 64. 128 on 3, okay. So then that becomes 192 over 128 is equal to k. So k is equal to, is that 1.5? Yep, so 1.5. Excellent. Once the, wait, is that all I need to do? Find a constant k. Once the cable car leaves the mountain station, how long should it take to return to the resort station? So it will stop and the test will be complete. Once the cable car leaves the mountain station, so velocity is going to be 0 here. It's going to stop at the mountain station and then go to the resort station. So the resort station is when v of t equals 0, and it's going to be the last one. So v of t equals 0. Cas t is equal to okay, wait, hold on. Since we found a new k, let's put these in. So k on 3 is going to be a half, because 3 on 2 divided by 3 is 1 over 2, so a half of t to the power of 3 plus 23 on, oh wait, no, that didn't change, so minus 23 on 2 t squared plus a half of 20, so it's going to be plus 30. T equals 0, and then we'll do cast now. T is equal to 1 divided by 2 x to the power of 3 minus 23 divided by 2 x squared plus 30x, minus plus 30x. So I get that it's equal to 0, 3, and 20. And then reaches, so cable car. So leaves the mountain station. How much should it take to return? So cable car to the resort station, the bottom one, and we're leaving mountain station. So cable car reaches mountain station at t equals 3, and it reaches the resort station at t equals 20, and then delta t is then going to be equal to 17 minutes. Unfortunately, 10 minutes into the test, the cable car breaks down. According to the engineer's model, how far is the cable car from the mountain station at this time? How far? 10 minutes into the test. So let's do distance. So this is going to be from, so 3 minutes is here, 10 minutes is here. It's all in the same direction. So it's going to be a positive. I don't know if it's going to spit out negative, so I'll just put absolute v of t from, that's going to be 3 to 10. So that's my boundaries. It's 3 to 10 of absolute value of, I'm just going to write v of t because I'm lazy. So then we got from 3 to 10, absolute value, copy and paste from here. dx is going to give me 1125 meters. How far did the cable come from the mountain station at this time? because it would have traveled that far in the 7 minutes. So I think this is correct. Alright. I got a physics exam to do, so I'm not even going to bother like checking through. I'm going to say that's it. I'm going to mark, get this done with, have dinner, do physics. Let's go. I've just finished marking, and quite disappointing. But we got 94.7%. I mean, it's not a bad score. It's just that I know I can get higher. There's 3 marks in calculator 3, and 5 marks in calculator assumed. I can't exactly remember what we lost in calculator 3, but I just marked calculator assume obviously, and oh boy, are they silly marks to lose. So 3 of those 5 marks I lost just because I didn't do what the question asked me to do. And if I did them, let's see what I get. 98. I would have got 96.6%. God damn it. Alright, well, here's what it is. But we'll go down. Here we lost 1 mark because I did the wrong probability. They asked for the probability after 8:25 a.m. So I should have done 3 on 5 because that's 1 minus 2 on 5. Because this is the probability from before, but I did before, so that is unlucky. And then we are continuing down. We got 1 mark here lost because this wasn't really that. You have to talk about the translation. Let me just bring up the calculator free solutions. And this is question 5. So you have to say they've both been translated in the same direction by the same amount, but then you also have to say that because it's a translation, both the graphs have the same shape, so the area between them doesn't change. So yeah, I lost 1 mark there because I didn't talk about the actual thingy. You could have said just C because it has the widest distribution, which, yeah, I mean, okay, seems I don't know, Memphis is really weird, where it's like, sometimes they want you to go super in-depth, and then sometimes you can say, oh, it's the widest. But yeah. Here I got the mark. I could have said, must be at least half of the area under the distribution graph, which is 1. The area is 1, but I thought my answer was definitely close enough. Yeah, I just need to talk about how it's not at least half of the area under the curve. And then the next one we lost, I think it's because I didn't, yeah. You had to explain why these are over or under estimates. What? I thought you can just say that under estimates and then just do it. But yeah, you have to explain why they are over and under estimates. So if it's an overestimate, it's because the top of the rectangles are above the graph. And if it's an under, because the top are under the graph. Which obviously, I know that makes sense, that's fine. But I feel like it's so like, I don't know. It doesn't seem like something I need to be able to comment on. But yeah. I guess because they say the areas of the rectangles, but man, whatever. Okay. I'm going to quickly swap to calculator assumed, and then we'll be back. And then here we are in calculator assumed. We lost 5 marks. So we'll just start going through them all, going down. I lost 1 mark here because it needed to state that there was not enough evidence. I thought just saying no and then explaining that why no is valid, but apparently you have to say, let's see, not enough. Okay. New sample contains the value of the proportion of the earlier sample, so I said that. So based on this, we can conclude there is not enough evidence to determine whether the vote is likely to vote has increased. Not enough evidence. So yeah, this is something more to add. I lost another mark here for my explanation. Okay, here I have 2 points I want to talk about. The first point is I just didn't talk about that it's Bernoulli, that it's a success or failure. You either vote or you don't. So that was another assumption that was the assumption I didn't make. The other ones that they were constant and independent I talked about. However, the marking key said that them being independent is actually a reasonable assumption. Which is, it's like, okay, it's a bit odd in my mind. Because then they also go on to talk about how it's dependent on things like age of the voter, occupation, economic status, and stuff like that. But they didn't talk about friends or families, political stuff like that. How, I mean, they're interconnected, they interact with the people around them. So obviously, if your mom and dad are more likely to vote for this party, you're probably not going to be independent of that opinion and their probability themselves. So the marking key just said you needed justifications with your assumptions. So I gave myself the mark. I think it's a perfectly fine thing. You can't tell me that let's say you're like what's going on? Oh, the American election. You can't be brought up in a Republican house and then say you are independent of their ideals. Well, it's very super unlikely that you're going to be so independent that you choose to vote Democrat. It's ridiculous. Yes, I have been following the news a lot. So Democrat and Republican are all in my mind right now. But yeah, let's go down. I lost. Oh, this was the other 3 marks. I can't believe I lost these marks. Oh, clearly indicate the location. I didn't do any of them. I just drew the freaking graph. Also, you could argue that my maximum here isn't actually a maximum, but I gave myself pity marks because I was so sad that I actually didn't do this. This was actually genuinely embarrassing that I didn't do it. So I gave myself a pity mark. My excuse for giving myself the pity mark is that the shape is somewhat there. And if I went back and checked, because I had, how much time did I have left? Let's check. I had 26 minutes left. That's more than enough time to check through all of these. Because methods you can check really fast. Just bing, bang, boom. It's not like Chem where you have to read through all your different answers over and over again to see if you include all the keywords and stuff like that. No, most of them are just calculations. You just put in your calculator and you get the right answer. You don't. So I will justify this as saying it is close enough, and I would have improved it if I thought. Well, I definitely would have improved it because I mean, yeah, whatever. It is what it is. So I gave myself 1 mark there for the overall shape. But everything else, inflection points, and then that going straight up like that was correct. I just needed to label them. Label the graph, and then everything down here was correct. Yeah, you can. This was I like this explanation better because it's more succinct. You just have to say that not all the confidence intervals will contain P. Only either 10% for the 90% confidence interval or 5% will. But yep, and then going down, all of this was fine. Bada bing, bada boom. Here they wanted you to talk about log 3 of x has the vert asymptote at x equals 0. I mean, I think that's ridiculous. That you just have to say that it equals 0, and it's only 2 marks anyway. So I would have got the mark because I think anything under 2 marks, as long as it's correct, you get the full 2 marks. So it's not like you can lose a mark in the 2-mark question. I think, I don't know, something like that. That's what my teacher told me. And then down here, everything else is correct. Here they just said that this equals 0. But I mean, I tidied it up a bit, which is, it still gives you the same thing. Let me check. Actually, let's see. Did I make an error with my simplification? Actually, no, I didn't, because I know I didn't, because the next few are all correct. And they are reliant on this. So this will definitely be fine. And then we have x plus e. X plus 5. I click solve. I think click solve. Nope, solve. Let's see what I get. Do I get 1.791? Oh, what a surprise I did. Okay, but yeah, that's the equation you have to solve. For this one, you could have said the 8th week after the changes are made. Which I mean, it's the same thing as after. I mean, 18th week because it's 10 weeks after. So I gave myself the mark because the mark there I think just identifies correct time, not necessarily that it's in the 8th or in the 8th week. What question is this? This is question 16. 13, 16. The term is the week when the profit exceeds 5 mil. Yeah. Okay. So you know, bada bing, bada boom. It is what it is. I identified it correctly. It didn't say it had to say in the 8th week. So yeah. And here 17 minutes was correct and 1125 meters. So that was pretty good. I mean, 94 point whatever it was is okay, but yeah, 3 marks lost to silly mistakes, 3 marks in calculator free, 3 marks. Oh, sorry. Okay, let's go to this. 3 marks I lost because of graphing. Actually, let me write these down. 3 marks lost. So calculator assume 3 marks because lost to not labeling graph. 2 marks lost because of my explanations, I think. 2 marks lost for explanations. 3. Oh, I only lost 5. 2 marks lost to explanations. I'm going to swap to calculator free. Okay, and then we lost 3 marks here because of not reading question correct. So calculator free, 1 mark, incorrect probability. 1 mark, incorrect explanation. 1 mark to retain same shape. And then I lost 1 mark because explain why over underestimate. Okay. And the 2 marks I lost in calculator assumed for explanations were not enough evidence. And what was the other one? Oh yeah. Bernoulli. Yes or no? Okay. So I'm gonna end it here. I still gotta edit that 2023 Chem video. So I'll get to doing that. I'll edit this down as well. Hopefully I can get these both out by tomorrow because I'm completely free tomorrow, which is excellent. So yeah, I'll get started on physics as well today and finish that tomorrow, and I'll do methods as well tomorrow. So yeah, I'll see you guys, I don't know, whenever. Goodbye.